Welcome to the demo of Medication Companion. In India, patients often visit multiple doctors. Every year, billions of prescriptions are dispensed, and most are written using brand names rather than generic drug names. Patients often visit multiple doctors or cardiologists, for example, maybe a cardiologist, a GP, a specialist, a local clinic, local pharmacy, etc. And those prescriptions may not get reconciled together for any harmful drug interactions. Medication Companion reads prescription photos, resolves Indian brand names to generic, checks for any drug interactions against the medication history. So when a patient logs in, this is the home screen that they see. And the app supports at the moment 5 languages, and patients can choose any language that they are more comfortable with. But for the purpose of demo, I will continue in English. So we have analyze prescription and pass prescription. Let me start with analyze prescription. They can either use camera or gallery. For the demo, I will choose gallery and I will pick up a text description. So let's take this and let's analyze this. So the tech stack has been explained in detail in the Kaggle write-up. There are multiple layers, but let's talk about the most important layer, the agentic pipeline. There are 5 agents in here. Agents 1, I call it the reader agent. It does the vision OCR using Gemini and also does the gate 1 quality check. Then agent 2 is the resolver agent. It maps the brands like EchoSprint to aspirin using deterministic drug lookup tools that I have written, and then it makes use of the drugs database. Then the agent 3 is the safety agent, and it checks every drug pair from the current prescription and the past prescription using Vertex AI Memory Bank, and it then tries to find any potential interactions. So now we can see the result is on the screen. So the remaining 2 agents I will talk about while going through the results. So let's go through the result. The summary is that there are some interactions it has performed that needs to be flagged to the doctor and needs to be reviewed. So the medications found 4. This is the job of the agent 1. It has read the prescription image and found 4 brand names, and it has shown those. Then the agent 2 has resolved those brand names to the generic names as it's seen here. The existing tag here is saying that agent knows about this drug. So when we get to agent 3, the actual safety agent, it makes use of Vertex AI memory, and it says that I know about this because some past prescriptions have already been uploaded. The patient is actively taking these drugs. And then the agent 3 uses again another deterministic tool where it finds all the potential drug interactions by looking at drug pairs one by one. And in this case, it has found 3 potential interactions. So it has flagged those interactions. So the interactions on the current prescription and in the past as well using the memory bank of the agent. And then so agent 3 has flagged those interactions. These interactions found, it has flagged them as high. We have the severity of high, medium, info, etc. And then the agent 4 is what I call the education agent, because its job is to look at all those interactions that have been flagged and create a summary of how to present that information to the user in a digestible way. And then it also prepares for a potential questions to be asked to the doctor so that patients can get a better explanation of what to do. And then the agent 5, the final agent, is the localization agent. It takes that summary, it converts it into the patient's native language if their native language has been chosen other than English. It also generates a text to speech for a audio of all the description.
This prescription includes several medications that may interact in ways that increase the risk of bleeding. The following interactions have been identified. Taking aspirin and SQLite together can significantly increase the risk of bleeding or stomach issues.
Now, as you can see, this is the final result. Now let me go back to the home, and here analyze prescription is there, past prescriptions is there. So let's go through the past prescriptions, and I will show you the various ways. So here for a given prescription, it has found some interactions that are of high concern, so flagged as high, but then this one is none, no interactions found, no potential harmful interactions found. And this one is where the gate 1 will already rejected because it was not a prescription. So it has correctly identified that this image is not a prescription, and it has decided to reject it. So this is pretty much it. All the other details like how I use the spec-driven development, what guardrails are used, like LLM as judge is used against the custom metrics for eval, how the performance against that custom metrics is done through eval, etc. All those details are covered in there. Thank you very much.